Hi, so I'm John Ross-Perkins. I'm going to try recording a small demo of work on the tool chain to sort of show how I think about it. Hopefully, I manage to do this without messing up too much. I've decided to work on the syntactic merging of function declarations because I think it's relatively small and maybe I can finish it today. I'll just mark that I'm going to work on that. For context, we already have semantic merging in the check layer. This is just adding another aspect to that where it also checks the syntax matching, and it'll do that by comparing the nodes in the parse tree. The purpose of this is that you can have a name in a function signature mapped to an alias of a type in one version of the signature and maybe not in a different one. And we just want to make sure that they're actually equivalent signatures. So I have open VS Code here and my terminal here. I'll create a small feature branch for this and go into the tool chain and make sure I have a build so that I can get incremental builds while I'm doing this. Then I like to often make a test to see what the current behavior is. I'm just going to copy, maybe not that file. I'm just looking for one that already has splits in it here. So I will call this syntactic merge, and I'm choosing to put this in the no prelude directory because I want to write something that has no prelude dependencies in it, at least as a baseline. Maybe we'll eventually want some prelude related tests. But I will delete all this boilerplate from the previous file. Everything up here will be replaced. Like, it talks about the old file name, but it'll be replaced when I run an auto update, so I don't need to worry about that. I do need to name each file here, so let's name the first one, just this is going to be the basic test of we have foo, well, can't use I32 because this is a no prelude file, and I32 requires the prelude. But I can do something like this. But the success cases are probably pretty well tested, so I'm not going to spend too much time on these. I will do a similar one, though, for two files. And here, though, I need to just delete that and make this an impl. So here we have two success tests. And now to sort of think about what failure tests are. So there's a pretty trivial thing here where the name just doesn't match, and I just want to see how that errors. And I should mark that as a failed test. The more interesting cases are going to be where we start getting into aliases, like alias C equals, no, that's not quite right. What do I want here? I want to do class C and then alias D equals C. So here we are going to do A is a C, and here we do A equals D. And note that these two are semantically equivalent because that's the same type, but they differ syntactically. That is to say, they are different types. And actually, this is making me want a different check in these. So I'm going to actually write the converse of those, where we have that showing that the alias is in both. And let's actually turn the two-file version into pretty much the same thing. So here, what you can see is the these should merge successfully because the semantics and the syntax tree of the declarations and definitions match. Here, I'm aliasing. Here, I'm again going to change this. How do I actually want to do this one? We're going to make this a double failure, so both the name and the type mismatch, to double check what the result is there. And we also want a two-file version of this. And I shouldn't name the API file that with a fail, because the API file will parse fine. It's only the impl file that will fail there. And really, it shouldn't matter where the alias is. I'm just going to put it in the impl file for locality. So let's clean up our library names. I'm trying to think if there are any other good examples we can test. I think until we actually have let template fully working, we can't actually get names matched over. So maybe this is good enough for now. So I'm saving that. I'm going to quickly run the auto update. That's going to run and show me where the current errors are. So we expect this because that's just a name mismatch. I've got an impl marker here. Fix that. Okay. So we have our clear actions here, which are these two test cases should be invalid. And that's our goal for today, is to make those invalid. So in handle function, which I'm working on function, so we're just looking at the handler for that. Most of the logic is actually in merge function redecal, which I just know a lot of at least some of what we're going to have to work with is here, the check function type matches. And for context, to avoid skipping too much, that's called at the top of merge function redecal. So in check function type matches, what we probably want is to first do the semantic matching, and if that succeeds, then do syntactic matching. We could do it the other order. I'm just trying to think through what will produce the best errors. We want to make sure we don't double error. And when I say error, I mean diagnostic, of course. Don't want to double diagnose. Anyways, so I'm going to put this here. Where am I? So here it's checking the parameters, then the return type, which reminds me we'll also want a test of the return type. So again, just double check that is semantically valid. Get unique library names. Okay, so again, we are at a clean test. I'm just reading through the function now, thinking how this needs to work. So I'm looking at the check reducle param implementation. We probably want to pass in here a range of nodes to check. One question would be, how hard is it to get the range of nodes specific to a particular parameter? The root node is going to be the last one. The one that should correspond to a parameter is the last node. And we can bound check that from the start. So the question is how we get the range of nodes appropriate for a given parameter. Or if we just want to do one pass for all parameters. It would be nice to actually have diagnostics aware of which parameter is the mismatch in order to spit out an index. But maybe it's fine if we just point to where the mismatch is. I think we're just going to point to where the mismatch is. I think that might actually be fine, and there are ways we could probably figure out which parameter it is if we really want to separately. This also means we may not need to track as much information, or at least it becomes a little easier to track information because we know we can just track the start and end of the bracketing the parameter brackets. Or is that the case? So I'm trying to think if we can pass this transparently to callers. We have the echolocation, we have the parameter refs. We could inject something into the parameter refs that tracks the particular range of parameters. So here's what we're going to do. We're going to just track the full, given there are two parameter lists, we're going to propose that we track a node ID for the start, and a node ID for the end. And this is, of course, bounds for so the important aspect here is I'm wondering if we can get by without tracking without tracking the implicit parameters separately. So just copying those from each entity. This means we'll have to add it to all of the entities, but that's probably a good thing anyways, because this same logic will actually apply to generics as well. And actually, aesthetically, it feels like this is probably closer to the location in concept. So I'm going to just swap the parameter ordering too. Okay. So now that we've added that, we have to go through each structure. So obviously in function, we can just copy these. I mean, maybe we'll end up wanting to refactor this later, but this is just kind of how the tool chain is set up right now. So class, function, and interface. And this also means we should probably add a couple more tests while I'm thinking about this. So class, no prelude, let's copy the syntactic merge file to the no prelude. So really, this is pretty much just a straight replacement of the keywords. We, of course, don't need to test the return type. Double checking I didn't miss anything, which of course I did. I'll leave that open, and then I'm going to make one more copy of this for interface. And it's like, this is pretty boilerplate. Let's just do the replace that way, and again, delete the in return. Okay. And this will fail to compile because I am non-initializing stuff. I should probably start doing that. So for now, I'm just marking these as invalid. I'll figure out how to get that data later. And this is just a to-do marker, so I can maybe find this again later. And similarly to before, okay, apparently this structure is a little different. And when I changed the order, I did not change the parameter order, so let's just fix that. There, so that makes the parameter order match. Interface should now be working better. This still needs the same as from handle function. And then one more copy into handle class. I will also fix this. So since this is changing the reference point for most things, we will also change the reference point for the first and last params. And this is probably also going to have to be copied over to the interface and function logic. How is merging? So right now, interfaces don't really merge, so we don't need to worry about that at least. Function merging is here. Okay. So I think that's at least some of the boilerplate stuff we need to do. Hopefully this actually compiles now. Of course it doesn't. Import ref. So on the import ref, the parse node ID is not going to match. This means the two file versions are going to be a little more complex to implement. Well, for now, we're just going to make it invalid. And this may actually be how that remains, and we may just need to notice when the declaration is an import ref to compare parse nodes from the originating tree. It just means imports are more complex. Imports are always more complex. So in global init, it's just manufacturing a boilerplate function. So we definitely are fine doing that there. That absolutely will not come back to bite us. Here for decal params. So we will probably need to start doing the tracking in here again, though. And because this will probably be the first file touch. I'm just going to do a really boring to-do. This version does not have any parameters. Yeah, namespaces have no parameters, so we don't need to do anything there. Okay, we're auto-updating again. We're going to take a quick look at where these are. Click name, redeclaration differs. So this is a separate issue here where interface imports aren't fully supported right now. So we're just going to mark this as a fail to do. We aren't going to try to do this in that or support it in this change because interfaces just don't support it. This one should fail, so it will just start failing for a different reason eventually. And double check. Yeah, so this is expected right now. Moving on. So I need to start tracking the node ranges. We're going to do that in decal params. We're going to be adding the first and last node IDs to that structure. I'm just looking again to copy my variables into decal name stack. So that structure there is going to be the name context, or at least I thought it was. Oh, it's a name component. Well, we'll need to decide at some point whether we want to enforce this on the full name component, but for now, that information does need to be there. I'm double checking how this is used. So I'm going to look at how parameters are pushed and popped. That is going to be in one of these files. Maybe handle pattern list. Yeah. So right now this is discarding the starts. Part of the premise of what I'm doing is that we actually want to track what the starts are. One way we can do this is by just not popping here. So we're going to start by trying that out. End and pop. Let's see how much information the parameter graph currently carries. So what we're looking for is really that node stack, so I can elide that now. And then here, when we have end and pop, no, I'm thinking about this slightly wrong. What is actually going to happen, I think, is rather, let me just copy that there. So what we're doing is we're just going to leave the nodes on the stack until it reaches here. And given that this is a conditional pop, we need to make sure that we are only popping the start if there is actually an ID associated. Let's actually do it this way. So we'll probably want to keep those. I'm just making sure I'm making a correct assumption about how the tool chain works here. There might be something else that is dealing with params in particular that I need to make sure has matching logic. And this too, I will need to fix in a moment, but I'm going to just work on this while that is compiling. So this is just to record the node ID. It's the actual error here. Yeah. Guess I can't use that due to how those are structured. And then we actually can just reassign that because we are only really trying to get at the first node. And then the last node ID should be that. In this case, though, we only want to mark the last param if explicit params aren't there. Or rather, and this seems a subtle detail, so I'm just adding a few comments. And to sort of emphasize the flow here, so something else was dealing with that probably. Impl is apparently doing some stuff with the implicit param list. Let's who is popping tuple patterns? So basically, Impl, I believe, is doing something slightly different with this syntax. So we're just having it dump the implicit param list art, and if that becomes an issue later, we'll just need to fix the impl code. So hopefully we're to something that doesn't actually, well, at least only fails on the tests we expect it to fail on now. And I'm just looking at the test output to verify this, and yes. So that is all good. Means we don't have any uses I'm not thinking of. Now we also have param lists. So what's happening here is that is produced by pop name component. Decal name stack produces it as part of the resolve as scope. Then I need to figure out how to wire this up in something like handle function. Or double check how this is wired up, I guess I should say. So back here, this is now just forwarded. And I had this same to do in a couple other spots, so I'm just going to clean those up too. Okay, so now we should be forwarding those on. I'm going to declare bankruptcy on my tabs and start over there. And then on merge, back to merge. So as I said before, what we want to do here is just make sure that redecal params match. And so this is checking implicit and checking explicit. kind of don't want to keep doing more nesting like that, so I'm just going to change the structure here a tiny bit. So I'm just thinking through which parameters I want to pass and sort of matching the signature of the previous calls. And, you know, similarly matching the signature, and actually that should probably be after urge. False if redeclaration parameter and for now I'm going to do so this is just noting that because the parse tree of a declaration is in a different file, we will eventually need to follow that. But for now, I'm just avoiding that because it's probably a significant bit of extra work that I'm not sure I would finish quickly. I may want to eventually pass these locations too. That's sort of what I'm looking at. But for now, we'll have parse nodes, and I'm just going, at least initially, I'll probably write a diagnostic that points at that specifically. Because looking at these previous ones, that's just kind of what we're doing. And when I say these different ones, I mean like the different diagnostics. These are just sort of noting that the redeclaration defers. It isn't saying in declaration of foo, which really we probably will want, but you know, haven't been doing it, and I don't really think it makes sense to do that as part of this change, particularly since I'm just trying to demo things right now. So we now have a set of parse nodes to check. We should make sure these are valid. And then we're also going to double check. Like, I don't think it's worth doing all of these inside the if. This is just sort of the double check that structurally we're and I'm just copy pasting the wrong thing, but double checking that structurally we're getting the validity. I'm assuming we will. So for comparing a range of parse nodes, we're going to want to reach into the parse tree and iterate over it. Because we have the first and last parse nodes, we can do a direct iteration. It's worth noting the parse tree is in reverse order, but we can still scan in linear orders. We just probably want to do the iteration in reverse to get it in like a more visually forward order. I mean, another option would be we could do a comparison and just take the thing that corresponds to the earliest token. But at least for now, I think it's fine if we just do the reverse. So let's see what functions the parse tree already has for getting a range. Tool chain check. And actually, maybe it's even a little more subtle than this. So this is where I'd been thinking about whether... So this may be one question of whether something with a space should differ from something without a space. That's probably not an issue. I'm going to just... The one thing I will do is just quickly ask on Discord. Or maybe I won't. Maybe I'll just do this for now and assume it's not an issue. But I will do a test to sort of point this out. So we're just going to do a pretty simple test here. And compare that with something that has no spaces. And for now, I'm just going to assume that we actually want that to be irrelevant. And similar to the other stuff, I will copy this into the other files, fixing my library name. Double checking where I am compilation-wise. Of course, this isn't going to work. So I was going to check what the parse tree is doing here, what APIs the parse tree provides, because we want to be able to iterate between these two nodes. And for that, we want to be able to make a range. So what's the post-order iterator actually doing? Because we could try using that iterator. Except my concern is I think this might make use of the child size, which I've been advocating that we don't need, or this subtree size. So what I'm going to do here is add this successor over the parse tree. So just copying this logic. What did I call that? First, last. I mean, really, I should probably, in this, given that this is an iterator, I think begin and end are more correct. Begin, and that is valid. And a so this is where things get sort of interesting. And I think I actually don't want that. I think I might be good just passing those in directly. Except for I want this to be inclusive of the end. I mean, not that it matters all that much, but it would be nice to have a clear behavior there, since we can't just and let's So I want to double check how post order is actually incrementing, just to make sure that I'm making a correct assumption. Yeah, I'm thinking that this does what I want. So getting back to the merge, what I now have here is I'm basically creating these two ranges. And then I want to see how LLVM zip behaves, because I think it might. I think the zip shortest is the behavior we want. I just forget what the default is. This probably means that it defaults to the shortest. Yeah, good. So that's important just to consider in case the two have different sizes, which would be a great thing to check. I probably don't need to do it there. So an example of where this would happen that we probably want to see how it errors is repeating a const. So repeated consts will still yield the same type. It'll yield an error about const, or a diagnostic, I think, about const being repeated, but we should be fine also indicating that the two declarations differ at that point. So this in particular is we have one taking in a const and the other takes in a const C, and these are syntactically divergent. And maybe I could have waited until I had more things working to actually copy the files. Maybe I will if I think of any more test cases. And again, double check the current behavior. I'm sort of expecting again that const produces a diagnostic. I will finish that in a moment. I'm just trying to see how this behaves. Badly. This is probably where I should have checkpointed a little more. That's my issue. So that was a small typo. When one of them is invalid, it should just return true so that the syntactic logic doesn't cause errors. And I'm going to just auto-updating one more time because there's a quirk where sometimes line numbers differ and I want to root out any differences. Okay, so this is looking good again. I only have the change size spec. Since I did that, I'm doing a quick add to sort of checkpoint my work so that I don't, like, it can just be helpful when a lot of tests are modified to be able to restore back to the prior state. And adding makes it really easy for me to do that. So back to this where I have the two ranges, I am now going to implement the comparison. So did I just, yeah, okay, so I'm just trying to remember. I do have the parameters in right, new, retrieve, new node id, retrieve node id, sip of new range, retrieve range. So one particular thing I'm relying on here is if, and I should probably document this, zip is using the shortest range. If they differ, the last node should differ. And like, actually, a better way to put this is there should be some difference inside the range, or the semantics should have a mismatch, such as a different parameter count. As a consequence, we don't care. We don't explicitly check that the range sizes are equal. Well, I should actually say don't explicitly handle different range sizes here. Okay, so I think that comment probably explains my thoughts, but going back onto here. So in this, we want to check that the two things. One is that context.parseTree.node kind of new node id node kind of node id context.parseTree.text. So it's, I think it's actually, as I go through this, it's going to be a little complex to compare the two nodes. So we're going to make a small helper function so that it's really clear and I have a single point of return. Tree.node kind of retrieve. So that checks the node kind. We only need to. I'm storing the kind because I'm new kind dot. I'm wondering if there's an easy way to determine if I need to check the spelling. Because, so there are going to be a few different node kinds that we want to check spellings for. Identifiers and keywords being the main ones. The flip side is something like const or, an operator, we don't really need to. But I'm not sure that there's a trivial way to check that. So we're going to just note this as a possible thing to change in the future. Actually, maybe I should just check identifiers. No, so my thing here, as I'm thinking about this further, is it's really identifiers and literals need their but keywords and operators shouldn't. But I'm not going to implement that right now. That might be a separate change just to keep this one simpler. What I am just going to do then, since I'm not really using the kind, is I'll undo that change. So how hard is it going to get the spelling? We're just switching that back to a context. Maybe we should have some helper for this, but I'm double checking that get token text doesn't have a check failure in it that I would need to worry about. So that's not ideal, just because it is doing some relexing there, and I don't actually want that. I want the underlying text, I believe. Well, for now, I'm just going to compare token text. Although this also has an interesting other quirk there of if a numeric literal so get token text is reformatting literal values. But fine, I'll just apply that, whatever. Don't really want that, but it's fine. So, of course, this returns true if the two nodes have the same syntax. If so, now I'm just using that function, doing a quick auto update. So ideally, we start seeing errors from this code now. Except for I actually need to print a diagnostic would probably be a huge help. So adding a diagnostic, So just actually. So just sort of mirroring the prior. One moment. Okay, I'm back after a brief pause. So I was just adding this diagnostic. So updating the text. The location is just the node ID. And with that, and similarly, we can do that. And then to add a diagnostic, we also need to go into the list of diagnostics over here. Technically, I should have just scrolled down. So diagnostic kind, redecal, param, syntax previous. Helps if I spell syntax correctly. So this auto update should show us where the actual differences are now. And then I'll look through the errors it produces and see what I'm actually getting. Declaration syntax. So that is expected. This is really a to-do because it's a cross-file error. We're not expecting that. I really want to do the return, but I'm going to just cut things out for now. This, though, should have failed. I need to dig into why it didn't. And then the rest succeeded, which is fine. Walking through interface. So again, that's all expected. Not even. I always feel weird about those spots because it's failing and it should stay failing, and I'm not sure that if I add a comment, it'll actually be helpful versus just confusing or like getting lost rather as time passes. So that's the expected. Similarly, that is missed there, and it shouldn't be. I will put a to-do here. Because importing interfaces doesn't work well. It should fail due to C versus D, but may succeed if importing is fixed before syntax matching importing chain on imports is fixed. Well, I shouldn't say fixed, it's really supported. And then here, we have a similar thing with const. So for some reason, I am catching the repeat const case, but I am missing the C versus D case. I will definitely need to look into that. Right. Okay. So that means my core tests that I'm adding, for the moment at least, seem good. Now I want to double check what's failing in these other tests. Test data, class, base method. I mean, I do think that this is an error under the new syntax. That should have been self there. And since we have this great test case, I will not lose it. Fail. Look at this wonderful test case I found. Let's. Okay, terrific. Oops. I'm just marking off the tests that I have verified. Wait, did I? Okay. So test data function built-in method. So this probably should not require self there. Or at least that should be a to-do. So let's... I'm not totally sure what will be triggering that one. I'll get back to that. I'm going to check the others first. So that's the same. Do not want. So class interface namespace. So I will just... What I'm thinking I should be doing is, in particular, also so that the return type ordering occurs correctly. For now, what I'm going to try out is what happens if we just make the question of whether to merge a Boolean. So most of these will want to check syntax. I'm expecting that only one or two actually will be checking with substitutions. And it's probably related. And looking at this, I actually feel better putting that last. So I'll be reordering that. that this doesn't. I'm just deleting that because I think it's better to have one call to like have everything that's using check redacle params match also check syntax, because that's the common case. So, no, I'm thinking about this wrong. So I think now I can look at what that changes. So this is good. We're back to just the small set of tests. And again, this one was modified because it had the name mismatch. But I'm still wondering what's going on with the alias we had. So I assume if I do this, that'll fail. Yes. So I wonder what exactly is going on here. Well, to sort of reduce the issue, I'm going to cut out all the other files. So now I have just this. I can just take that command and run the file directly and sort of see what's going on. And what I especially want to do here now is So this is just my own habit, is I tend to do just log-based debugging, but I want to see what it's really comparing. So, wrong command, do the Bazel run again. So, why is it comparing D and D? Well, this works better if I actually use a different name. And this is why we write tests. Ta-da! Okay. And I need to undo my other debug statement too. But that shouldn't actually affect the auto-updated files. It's just going to errors directly for me to look at. So syntactic merge here, redeclaration syntax differs here, terrific. That is the error we are aiming for. Spacing, redeclaration syntax differs here. And then there's this alias test. I no longer need that. So I'm just going to remove it. So now I have this change. I need to double check that it actually passes tests. I might have missed a file name, like a fail label on something. So it's always good to double check. That's looking good. So I'm just going to commit this, implement syntactic merges for parameters. I should say syntactic merge checks for parameters. So I usually just use GitHub to double check the diff that I make. Here we can sort of see we have the decl parameters, and then it's just sort of forwarding on the information to the call. Similarly here, we now have this check syntax parameter. This is as intended. This is just copying the information through. Similarly in here and here. Maybe I'll add a note to handle pattern list about what's going on with the start nodes. So just noting the start node remains on the stack. The parameter list, I'll just say param list handler and similar here. And fixing node to node. So just documenting that detail, continuing on. So going to slightly change the commenting and merge there to more clearly explain, like, compare and that sort of shifts the to-do a little as well. Okay. I think looking over this change looks good. So the last couple touches are to put on a couple notes about the caveats here. I know this isn't implementing import support. The parse node there is harder to access through the context. Will require examining, well, I should say would require examining in order to get the import declaration to get at the original header. We also don't have a parse tree attached in that case. We would need to add one to Semmer, or Semmer file. I believe we do want to add that so it's explicitly a to-do. Were there any other to-dos I added? Get token text. I could note that too. Current support for comparing nodes. Tokens is also limited, so there will be some edge cases this misses. And maybe I can actually add a test case that shows an edge case. And I'll just do that in class maybe because it feels like more of a classy thing. Yeah, I think this is I think this one is easier to write with the prelude. So what we're going to do here is have class C X I32 for A I32. And then class B, which takes in a B, which is a C of 1.0. Well, let's actually do it this way. 1 and 1_0. So again, do a quick auto update. I thought it. So we probably need to get rid of that error. But for now, I will just fix the code to apply it. Okay, I wasn't expecting that to get caught, but I guess it does. So what is get token text actually doing again? I guess the relexed token must just be returning the same value. So maybe this is actually fine and we don't need to change it. Though it's a little weird that it relexes in order to get the text. Well, I will add that as a note. No, so that's a storage thing, isn't it? It doesn't necessarily know when that token ends. So I'm just going to remove that because that actually works. That changes this note. So one more auto update just to make sure that everything's good. And actually I know it's not because that should be mismatch, just test again to make sure that everything is ready for upload. But I think that this change is basically done at this point. I have my to-dos, but the core logic works and is clearly doing some syntactic checks. Oh yeah, and I just like to have things in a single PR at least, or a single commit rather at first. So I use git stack for that. And then create the pull request. Triple check everything, and I think we're done. Thank you.